Hello, class. Hope you guys are doing okay. Here I'm making a video on our second section of our fourth unit, which is on chapter 3. And as you can probably tell, chapter 3 is pretty heavy on algebra, in this case, solving. And don't mind the washer in the background. Actually doing this in my home office here about 6 in the morning here on Thursday. Anyway, so this is about rewriting equations and solving by rewriting. So let's just get to it. I could read all this like blurb stuff, but let's just get to the first example here. So Graciela is trying to solve this equation, x squared plus 2.5x minus 1.5 equals 0. And it seems kind of tricky, and you probably might want to use quad form. And if you remember the quad form is this. Let me pull up my annotation tools here. All right, perfect. Cool. Yeah, quad form is this, right? X equals negative b plus or minus square root of b squared minus 4ac all over 2a. Some people turn it into a song. If you want to do that, it doesn't really rhyme, but anyway, you could do that. But it might be more efficient to rewrite the equation because doing quad form to decimals, especially if you're squaring like 2.5, could be really tricky. And what if you didn't have a calculator with you, right? So Walter says we should rewrite it. So it has no decimals. What I would do is multiply both sides by 2. Because if you multiply anything that ends in 0.5 by 2, the decimals will go away. So I multiply the right side by 2 and the left side by 2, so it's fair treatment. So you get 2x squared plus 5x minus 3 equals 0. Okay, so part A is done. Now part B, rewrite it, this time expressed as a product. That basically means factor. Because you got 0 on the left, on the right side. Well, if you factor it, then you can set each factor equal to 0, and you're set, right? Now, we talked about factoring the other day. Excuse me. Remember, we do a times c up to here, which is negative 6. B down here, which is 5. Find two numbers that multiply negative 6 and add up to 5. That would be negative 5 and negative 1. And then we could do a little box like this here. 2x squared in the upper left corner, negative 3 in the lower right corner. And you can put negative 5x and negative x because the whole point of doing the diamond was to split the middle term, right? And I just messed up. I'm not going to redo this video, okay? I just messed up. Okay, you got to multiply negative 6 and add up to negative 5. Okay, good. Hopefully, you're wondering what the heck am I doing wrong? Again, 6:13 in the morning here. So anyway, my apologies. 2x squared, negative 3, and then 6x and negative x. And I caught myself, I'm human. I caught myself because I realized, wait one sec. I'm splitting the middle term. Middle term is 5x, right? So 6x negative x, that makes more sense. Definitely I'm going to do 2x here. Just 2x can be factored out from the first column. Therefore, this is x. That's negative 1, and that has to be 3. So x plus 3, 2x minus 1 equals 0. X will be negative 3 or 1/2. And there you go. So we're able to do that quite effectively without having to use quad form, just by being very resourceful, realizing, hey, I could get rid of decimals by multiplying by a certain whole number, so there are no more decimals, and I can factor afterwards. So that's what we want to do when we're dealing with algebra. We want to be efficient with our techniques. So here's an opportunity for you to do that. I really like this problem a lot, and it follows well from the previous problem. And with your table group, find an equivalent equation or system that you think will be easier to solve for parts A through F, and solve your new equation and check your answer by using the original equation. Meaning, plug the answer you get for X back into the original. So I'll kind of give you some hints here. What I would probably do for this one is divide everything by hundreds. So actually, hold on a sec. What I do here is probably multiply everything by 6. For D, multiply both sides by x squared. For this, I'd probably multiply this by 5 and then add the equations. That's a system of equations, by the way. then you'll get 15x plus 10y equals negative 20. 35x minus 10y equals 120. Use a calculator if you need to. Then add the equations afterwards. For E, oh boy. That's not really easy, but multiply both sides by x and x minus 1. That's the LCD for the left side. So that way you get rid of fractions. And this one here, I would substitute for the radical. That'll equal 5 times 2y. And then you'd have 3 10y minus 3y equals 27. So I kind of gave you some leads here. So go ahead and pause the video, try solving each of these. And then obviously unpause the video and I'll show you the answers. Okay, hopefully you took some time to work those out. I took a few minutes myself. Of course, maybe just kept watching the video and the answers just showed up. I didn't want to work through the process in the video because I wanted really you guys to work through it. And of course, I didn't want the video to be too long either. So obviously, you know, as you're playing the video, the answers just show up, right? Because I paused my recording on my end. So let's just walk this really quickly. So A, I did in red, divide everything by 100. Got x squared plus x equals 20. And then move the 20 over, factor, that's pretty easy to factor, x plus 5, x minus 4, we get negative 5 and 4 using the zero product property. If you look at B was substitution, also did in red. Multiply both sides of the second equation by 5, that way the y's will cancel when I add the equations. You get 35x minus 10y equals 120 for the second equation. We multiply both sides of that by 5. Add the equations, the y's cancel, 50x equals 100x equals 2. Plug 2 back in either equation, you should get 2 common negative 5. Looks like I plugged 2 back into the second equation. And you can check by plugging 2 negative 5 into the first equation, make sure it makes sense. And it does, because you get 30 minus 50. And going back to part A again, if I plug in 4 negative 5 in for x into the original, it should work itself out if you were to do that. Yeah, excuse me, it does. For C, the one with the fractions, multiplied both sides by 6, since that's the least common denominator of 3 and 2. That I did in green. You should get 2x squared plus 3x minus 2 equals 0. I didn't quite do the diamond or the box, but I trust you guys can factor that correctly. You should get 2x minus 1 times x plus 2. You get half and negative 2. For D, I did in dark blue. The least common denominator is x squared, because that way you get rid of fractions. So you want to get rid of fractions, right? Just like I did in part C. So if you multiply both sides by x squared, as I had mentioned earlier in the video, you should get 4 plus 12x plus 9x squared. That's a perfect square trinomial, which could factor very nicely like that. 3x plus 2, 3x plus 2. Boom, x equals negative 2/3. E, I did in pink for Breast Cancer Awareness Month. Anyway, I just picking colors, but still good for breast cancer awareness. Anyway, multiply both sides by x times x minus 1. And yeah, the reason why I did that, because that's the denominators I see in all the fractions. And you got to be careful there, because if I multiply the first fraction, x minus 3 over x by x times x minus 1, the x is canceled, right? So I get x minus 1 times x minus 3 right here. And if I do the next fraction, 2 over x minus 1 by x times x minus 1, x minus 1's cancel, I get 2x. Then if I multiply 5 minus x over x by x times x minus 1, because you got to do everything when you're multiplying the LCD by all sides, the x's cancel. 5 minus x times x minus 1, FOIL that out, get that. And then, yeah, just combine like terms and factor and pull the 2 out and you're good. And that's also a perfect square trinomial. So you get that. And then lastly for F, I'm trying to demystify, how complicated these equations can be, because that looks complicated, right? But if you think about it, you see the same radical in both equations. Why not just substitute? So I did in purple up above. For the first equation, I multiplied both sides by 2y, got the radical by itself, and then replaced the entire radical in the second equation with 10y. And now it becomes a simple linear equation, and you can solve it. So this requires some critical thinking, obviously, but if you just look at the equations and see what you can substitute or get rid of, You could totally demystify this process. It's not really anything too challenging. You guys could totally do this. All right, let's keep moving. Here we want to write equivalent equations. So for 341, we're asked to do is a solve for y, so get y by itself. And then the next one, 42, for part B, you're asked to get x by itself. Well, these should, 41 should be pretty easy, right? Shouldn't be that bad. We'll go red for the 49ers, not purple for the Vikings. We play next Monday. So just get y by itself, negative 2y equals negative 5x plus 8, divided by negative 2, easy peasy. And you can leave it like that. You don't need to simplify anymore, it's all good. Here, get y by itself, xy equals 2 minus 3x, divide by x, 2 minus 3x over x, boom, 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 easy peasy. And you'll want to be very fluid with isolating variables because you'll need to do that in your future math classes. Like you'll just have to you'll be doing some calculus or pre-calculus type stuff, and you have to get one equation in terms of another, blah, 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 or using the variables. Usually a good idea to isolate a variable and plug it in for another equation. So you want to have that, you want to be good at that skill. Solving for x for part B. Now that's tricky because I see x in two places, and I've seen, don't write this down, but I've seen some students do this, like, well, let me, move the 3x to the right side, and let me divide by y, and they think they have it isolated, right? Well, you don't, because you have x in two places. It's not isolated. So you have to get a little creative here. Fortunately, all the x's are on the right side. You just factor it out. That's a key step. I put a star there because if this were a test problem, I'd make most of the points worth that step. Factor out x. And then divide by y plus 3. Because x is now being multiplied to y plus 3, so you divide by it, doing the opposite operator, right? Now, just something to keep in mind, what if the equation started off like this? Then what you want to do is collect all terms that have x. That's what you want to do. Collect all terms that have x. If you're being asked to solve for x, of course. But fortunately, all the terms of x were already on the left side, and that made it easy for us. Almost done with the notes. And then you guys can get a head start with homework. Are any of the three equations below equivalent? Justify distance by rewriting each of these equations as an equivalent equation. Okay. So what I'm going to wind up doing here, hold on a sec. Okay. Is maybe isolate y. That might help. And kind of see what happens. Here I'm going to divide everything by -1. Not, oh, yeah, not quite the same. So first and third ones are not the same. They're almost the same, but not quite. Here, oh boy. That is insane. Okay, I'm going to factor on x. Oh yeah, there we go. Now we're talking. That looked a little crazy at first, so don't foil the right side because you're gonna really drive yourself nuts. Those cancel. So then these are the same and not the first one. So, but you just got creative, right? Factor out the x, simplify, and you're good. Okay. Oh, we're not done yet. There's still one more example. I lied. All right, let's take a look at this one here. Then we're done. So Angelica and Dili were working on finding the roots of two quadratic equations, blah, blah, blah. Angelica managed to claim, look, she said, when I solve each one for y equals 0, I get the same solution, so these equations must be equivalent. Not necessarily, and that's because of the 2 there. Yes, they do have the same roots or the same x-intercepts, but whoop-de-doo. Doesn't mean the same y-intercepts are going to be the same, or doesn't mean they're going to point in the same direction. How can it be equivalent if one of the equations has a factor of 2 and that the other doesn't. So who is correct? It's totally delete. Totally. For example, what if you find the y-intercept, right? For the first equation, the y-intercept is going to be 15. For this one, that's going to be 30. So that right there proves they're different. Also, if you graph them, sure. They both do this, right? But one's going to cross the y-axis at 30, where the other one crosses the y-axis at 15. So, and then are the solutions equivalent to the solutions? Well, yeah, they are. That's because you set each factor equal to 0 and solve in each case. X is 3, X is 5. But, here you have a 2. I mean, fine, there's a 2 there, but 2 is just a constant. Same thing, X equals 3, X equals 5. So the solutions are the same for sure, but doesn't mean the equations are equivalent. Because, the 2 obviously changes things, makes the equation skinnier, right? And has a higher y-intercept and blah, blah, blah. So anyway, I think that is pretty much it for the video or for the lesson. So just a quick summary and some vocab. Binomials, make sure you know what binomial means, 2 terms. To be a polynomial, you have to have x raised to some power and a whole number power. That's very important also. So that's just some of the stuff we'll talk about later on because we're going to be getting the polynomials. Coefficients are numbers in front of the variables, but if you don't have a variable, you call it a constant term. But yeah, as long as you have a real number times x raised to a whole number, if all the terms look like that, that is a polynomial. So like x cubed plus x squared plus x plus 1, that's a polynomial. Even if it's just one term, we call it monomial. It's still a polynomial, I suppose, even though it's not poly. It's not many, but but if you have like x raised to the -5 power, forget it. Or x raised to the 2.5 power, forget it. That's not going to work. Or 2 to the x power, like you see here, that's exponential, not polynomial. Or x in the bottom of a fraction, forget it. Not going to work. Homework should be fairly short, just 5 problems here. And if you want to try some extra problems, 63 and 67 are good problems. So this one here is asking you whether these are equivalent. That's great. 49's going back to old stuff, exponential growth. 50 is asking you to factor. 51 is looking at equivalent equations again. 56 is going back to like linear functions, that looks like. And 69 is just more foiling, or yeah, looks like foiling. So pretty easy homework, not too bad. And I think we're all set. Okay, well, work hard, make good use of the period, and I'll see you guys on Monday. And of course, if you're my Friday students, I'll see you in person, but you can have this video to watch for later on. Okay, great. Let me go and clear the screen and stop the video.